This video is going to be about solving rational functions, equations, and inequalities. And the first example I'm going to talk about is a simple one here in green, where I have a rational function 2 over x, and I set that equal to 0. When I look at that, is there any value of x that I can plug in there to make this whole fraction equal to 0? And the answer is no. I can't put in one single number to make 2 divided by that number equal to 0. The only way a fraction can be equal to 0 is if the numerator is equal to 0. So we have to carry on that thought for solving these rational functions, equations, when they're set equal to 0. This next example, I have a ratio. I have two factors on top, x minus 7 on the bottom. So when I see the x minus 7, I know my domain's all real numbers except 7, like I have listed here. And to actually solve it, I'm going to set the numerator equal to 0. So when I set the numerator equal to 0 and I go to solving, I get x equals 0, x plus 5 equals 0, which is x equals negative 5. So my two solutions are 0, negative 5, but you have to remember to check it against the domain. And since neither of those are 7, they're both solutions. Next one I have here is a little more complicated on top, and that's what's going to happen for you many times. I have to factor the numerator, but before I do a quick check on my domain. My domain here is all real numbers except 4. When I factor that numerator, x minus 4, x minus 3, and that leads to x equals 4, x equals 3. But again, when I check these against my domain, 4 can't be a solution. So the only solution I have is x equals 3. So that's solving rational equations. You set the numerator equal to 0, check your domain, and that's about it. The next thing we're going to talk about is solving inequalities. And this is going to be called the sign pattern test. And I'm going to just do a simple thing here. It's a very simple rational function if you think of it being divided by 1. But I have these two factors less than 0. And I'm going to look and see what makes these factors 0 themselves. And that would be 5 or negative 6. And then you draw a number line. And in class, I'll draw this in little marks above these numbers. But here it's a little tougher. So I'm going to put the zeros I have for each factor in yellow. And I'm putting numbers in order. Like I need a number between negative 6 and 5, 0. I need a number bigger than 5, so I chose 10. A number less than negative 6, I chose negative 10. These numbers in black could be any numbers as long as they are in order. This has to make an ordered sense. I take my factors, write them down here on the left. And what you do is you visualize putting the negative 10 in for this x. And I don't care what the value is. I just care, is it positive or is it negative? And in this case, it's negative. I put negative 10 in for this x. Negative 10 plus 6 gives me a negative number. I repeat for the zeros. Put 0 in, I get negative. 0 in here, I get a positive. Do it for the 10. 10 minus 5 is positive. 10 plus 6 is positive. And then I look at this function. And if I'm multiplying them or if I'm dividing them, you're just thinking about what the signs are. If you multiply or divide two negatives, you get a positive. If you have an odd number of negatives, you get a negative. If I have no negatives at all, it's going to be a positive. And then you look at these signs here, and that tells me that this function right there is less than 0. That means it's negative, from negative 6 to positive 5. These endpoints are always going to be what makes these different factors or terms 0. And I do not include the endpoints because this is strictly less than 0. Next example, I have this function is less than or equal to 0. I have a factor on the bottom, x plus 3. So my domain is all real numbers except negative 3. I'm going to keep using that negative 3 because it makes that one 0, but I have to bear in mind I can't include that in any endpoints, because if I were to plug a negative 3 in, I would get division by 0. My other two would be 2 and negative 1. I draw the number line, and I'm putting all my numbers in yellow, the negative 3, the negative 1, the 2. I'm picking what I want for numbers between them or outside of them. As long as it makes sense, as long as it is in order, it's fine. And then I repeat the process of plugging negative 5 in, seeing this is negative, negative, negative. 3 negatives gives me a negative. Put negative 2 in, I get a positive, I get a negative, I get a negative. even number of negatives. This is going to be positive. Go ahead and pause it, check the other two, make sure I'm right. But this is going to be the order you get on this one. And I'm looking for where this is less than or equal to 0. So again, I'm looking for the negatives, but I have to be careful. It's negative from negative infinity clear up to negative 3, but I can't include the negative 3 because it's not in my domain. So that's why I have a parenthesis. Union with, well, negative 1 and 2, I do include, because if I plug either of those in, it will make it equal to 0. So my whole solution is this interval notation I have right there. The next one, again, I have a ratio. My domain's all real numbers except 0, negative 11. So the numbers I'm going to use are negative 11, 0, and 3, because it makes the numerator 0. Make out my list. Make sure they're in order. That's the biggest mistake people make, including myself. You have to make sure you have these in order and go through the process of plugging the negatives in. And when I'm all done, I want this one to be strictly greater than 0. So I'm looking where it's plus. Well, it's positive from negative 11 to 0, and it's positive from 3 on, so 3 to infinity. And I'm not including any endpoints because it's not equal to. I wouldn't include negative 11 or 0 anyway because that would give me division by 0. So when you look at these, it's going minus, plus, minus, minus, plus, minus, plus, minus, plus. Most of the time it's going to be a pattern similar to that, but not always. Here's an example of when it's not. I want this greater than or equal to 0. My domain's all real numbers except negative 2. And the two ones I'm going to look at are 1 and negative 2. I put my numbers in order, pick the ones I want, plug them in, and I'm noticing this top term, the x minus 1 squared, is always positive. And when I count up my negatives here, well, these are positive, positive. One negative makes it negative. So I want basically this to be greater than or equal to 0. That's going to occur from negative 2 to 1 and 1 to infinity. So when I write it out the first time, I'm writing this, negative 2 to 1, including the 1, union 1 to infinity. But since 1's included in both, I may as well just rewrite this as negative 2 to infinity because it could be equal to 0. If it was just strictly greater than 0, I'd have to go with this first interval notation. And the last example I have is kind of a special case. Here I have a constant, and you notice it's a negative constant. So if this constant is negative, I'm going to include it down here. I got the x plus 1, I got the x plus 9. Right now you're probably following this, I hope, fairly well. I have a negative 9, I have a negative 1. Pick my numbers, and I notice this top row is always negative because of that negative 7. I have to add that in because that negative changes the count, and I would end up with this being negative, positive, negative. If I didn't include that, I would have these signs completely backwards. And I want this to be strictly greater than 0. Well, that's going to occur from negative 9 to negative 1, not including any endpoints.